Good evening, ladies and gentlemen. My name is Ravindranath Goswami, and it is my pleasure to be your host for this evening's webinar with the topic, Weather Systems and Their Impacts on Trinidad and Tobago. A warm welcome to all attendees viewing the live stream via YouTube from Trinidad and Tobago, the wider Caribbean, as well as globally. Please note that this event is being recorded. Welcome to our distinguished presenter, whom you will hear more about shortly. REACT is the Radio Emergency Associated Communications Teams, a voluntary non-profit organization that provides assistance in times of emergencies and disasters, working closely with first responder organizations and partners. Headquartered in Glendale, California, REACT started in 1962, with operations commencing in Trinidad and Tobago in 1964. The organization has therefore been providing service to the communities for well over 60 years. REACT operates on the basis of chartered teams. There are 10 such teams serving Trinidad and Tobago, as well as an umbrella body, the REACT Trinidad and Tobago Council. Members give up their time and assist with public service projects, including cultural, sporting, and other activities in which communications and logistics are critical. Radio communications technology is the mainstay of the organization's operations. Continual preparation via training, exercises, drills, and projects is key to the organization's preparedness activities. REACT works closely with several stakeholders, and it is through these partnerships that we host sessions like today. The month of May is celebrated internationally as REACT Month. May has also been declared as the National Disaster Prevention and Preparedness Month by the Government of the Republic of Trinidad and Tobago, with a program of activities executed by several stakeholders led by the Office of Disaster Preparedness and Management, ODPM. REACT has had a long working relationship with the ODPM, and today's event is a manifestation of this continued close collaboration. We acknowledge the long-standing partnership with the Tobago Emergency Management Agency, TEMA, the Trinidad and Tobago Meteorological Service, TTMS, as well as Heartlight TV, the streaming provider for today. The genesis of today's event arose out of discussions with the NDPPM Secretariat in 2021, under the leadership of the CEO of the ODPM, Major General Retired Rodney Smart, and Operations Manager Dennis Marcel. In 2021, we addressed the topic of the role of radio communications in disaster prevention and preparedness. In 2022, we discussed women in emergency communications and disaster risk reduction. In 2023, the topic chosen was the role of weather in being disaster ready. And in 2024, we addressed innovations in volunteer technologies for disaster resilience. To access recordings, simply search for the terms NDPPM and REACT on YouTube. The feedback from these past events have been encouraging and inspirational, and REACT is pleased once again for the 5th consecutive year to partner with the ODPM and other stakeholders in hosting this evening's webinar, Weather Systems and Their Impacts on Trinidad and Tobago. We have already had the declaration of the start of the wet season on the 19th of May, and the Atlantic hurricane season begins tomorrow, the 1st of June, which makes these discussions timely. Therefore, collaboration and cooperation among agencies and stakeholders are critical if we are to have an all-hands-on-deck, all-of-society approach to disaster risk reduction. Without a doubt, the weather and understanding its various aspects, as well as the related topics of climate change and climate variability, are of utmost importance, with knowledge sharing and training being key elements if we are to be better prepared and adapt. The overall theme for the NDPPM for 2025 is flood mitigation becoming more resilient. We can therefore make the clear link between our topic this evening and the objective of this year's focus. As such, this evening, we have a qualified and experienced subject matter expert who has put together an extensive presentation for us and who will be introduced shortly to take us through and explore the topic, weather systems and their impacts on Trinidad and Tobago. We will do a deep dive into the recently presented 18th National Climate Outlook Forum, or NCOF, as well as the type of weather systems experienced in Trinidad and Tobago. Additionally, we will review the 2025 hurricane season forecast. We will also be having question and answer segments for webinar attendees to submit their questions. Attendees may send in questions to the panel via SMS text or WhatsApp. And the number for sending that text message, your question, or via SMS text or WhatsApp will be 1-868-74-REACT. Again, that number, 1-868-74-REACT. That is also 747-3228. Again, 747-3228. And you can send those messages, your questions, at any time starting from now. So we certainly welcome your questions. We will also attempt to monitor the YouTube chat and discern if there are any questions there as well. Now, a disclaimer, should we encounter any major technical difficulties or other issues that affect the program, we will attempt to recover. However, if we are unable to do so within 5 minutes or so, we will seek to then reschedule. Please note that we will be proceeding quite informally throughout the evening. So sit back and relax as we hear from our distinguished presenter. Gary Benjamin started in the field of meteorology with the Trinidad and Tobago Meteorological Service in 1981. First as a weather observer and eventually a meteorologist, an aeronautical meteorologist, a synoptic analyst, and a weather forecaster. Quite a mouthful. He has considerable experience in analyzing and predicting the state of the atmosphere in WMO's Region 4, and I think WMO is World Meteorological Organization. He is also trained in basic climatology and agrometeorology. Gary has done several FEMA courses in emergency management, for example, NIMS, ICS, emergency planning, etc. He is trained in CERT and is a licensed amateur radio operator. He possesses a technician diploma in telecommunication systems and a BSc Information Technology from UWI. Gary is a member of the Radio Emergency Associated Communications Team's REACT. He is presently employed with the Trinidad and Tobago Meteorological Service as a meteorologist based mostly in the communications department and also performs duties at the synoptic branch. So without any further ado, I hand you over to Mr. Gary Benjamin for his presentation.
Thank you very much, Robbie, for that introduction. You know, every time I hear that, it seems like much of a mouthful, and I tend to turn around and see who are they speaking about. But over the years, little bit by little bit, tend to add up. So yes, I appreciated that introduction, and also a pleasant good evening to you and to all the listeners and the viewers from wherever you may be. I hope to have a good evening with you in the sharing of knowledge so that we would walk away from here with that much expanded amount of knowledge and able to respond to any weather adversities which may threaten us or affect us, so that we collectively would have that extra information to respond appropriately. Now, I have put together a presentation this evening. It is very expensive, and I did submit a similar one a couple of weeks ago, but this one has been expanded and have introduced some other parts of it that was not presented before. So I hope to give you a good, full, mouthful, earful, and brainful, and we would walk away to this evening, better much informed and therefore able to respond for the purposes of keeping our countries, Trinidad and Tobago and the Caribbean, wider Caribbean, as safe as possible as we can with our resources. So without further ado, I'll go to the presentation. Share my presentation. Okay, so it's up on the screen now, supposed to be up. Right. So this presentation, of course, is weather systems which usually affect Trinidad and Tobago. I'm not getting to move down. I'm not getting to control it. All right, yeah. All right. All right. I know it. So we really want to be able to help each other, to work together, to help each other so that we would have a better country, a more safer country. And it is my hope by this presentation, little basics of our weather and climate, we can have a perspective and indeed an interest and of course desire so that all of us, wherever we may be in our different stakeholder agencies and areas in life, that we could have some knowledge and resources to act in a way that we could help to prevent and mitigate against the impacts of weather events which are likely to affect us. So we first want to look at the dry season, the weather patterns in the dry season. Normally people think the dry season is just a dry season, especially in January. There are no possible disasters, just dry in the sun. But with the dry season, it is not devoid of rainfall. We have some passing frontal systems because of the winter period in the Northern Hemisphere, which will generally move from west to east and create shear lines. We also have mid-level troughs. We have varying surface convergence out of the Atlantic high pressure cell. Because it is closer to us, it is usually stronger at that time. And because of the proximity, we have stronger increase in wind strength from surface to the mid-levels, which would, of course, cause bands of convergent clouds. You also have hazardous seas as a result of wind friction at the sea surface. Also, we have the subtropical activity generating long period swells, which could become hazardous as they enter into our coastlines. We have low-level easterly wind maximums, which when encountering the land breeze in the early morning just before sunrise, we could get some showers occurring. We could have also the assistance of the orographic assistance, meaning the assistance from mountains and elevated areas. And by April, we see the intensity and frequency of Saharan dust episodes, one of which we are experiencing right now. It is also by April to May, we have the beginning of the yearly heat season and the first peak, usually around April and May. Also, the increased likelihood of isolated thunderstorms during April and May. And also, can't forget, it's a dry season. So we're looking at possible bushfires, increased surface dust, smoke, and dried particles in the atmosphere. So with all of this, what happened? This is a picture I'm showing you on screen. It is an isobaric surface analysis. And it shows in this one, if you look to the left of the analysis, you see the blue triangles that represents a cold front. And to the end of it, you see a shear line. And just at the bottom of the dashed lines is showing an induced perturbation moving from east to west or from right to left in the picture. And these could tend to increase some showers over us in the dry season. The next analysis would show the frontal system much closer. And you could see one perturbation coming up against the frontal system, one moving one way and the other, colliding, so to speak, and causing some showers, some heavy showers would cause some heavy showers over the Leeward Islands, and we see an extended one and induced connection over the tropical areas just to the east of Trinidad and Tobago, and that would bring some showers also. So the dry season is not devoid of showers. I've never seen a month in the year which would not have had a thunderstorm at least occurring for some time, some years. We also look at this. This is a numerical model, a broad scale one, that shows just to the north of the Les Antilles an area of low pressure. And as we zoom in a little bit, we could see how these areas of low pressures and that down to the end across the central island is convergent area going into the low pressure area, and that could bring some showers for Trinidad and Tobago. Also to the south of that, we see well, that could bring some showers for the central islands, and over to the south of that, over Trinidad and Tobago, we would have had a thunderstorm or two, and that was in April. So the dry season is not devoid of rainfall, and it is not devoid of its hazards. We see a geocolor picture showing just to the east of Trinidad and Tobago, those cloud bands you see in there, those cloud masses generated from the friction across the sea. And to the north of that, you see an elongated white line that is depicting the frontal system. So the dry season has its hazards, and one of the hazards that we get is the rough seas, and the rough seas generated, of course, by the strong high pressure cell, which is closer to the tropics. And as we come across on the equatorial side, it would generate some strong winds and bring those friction waves, generating those waves, and they come into shore and create some hazardous seas for us. One of the, also besides the hazardous seas, we have long period swells. The North Atlantic subtropical or temperate areas have areas of low pressure, cyclones actually, that generate these long period swells, and they travel across the ocean, similar to tsunamis, much like tsunamis, which they wouldn't have much height across the open ocean, but because the energy is to a certain depth, when it comes in onshore, it crashes on the land and it could destroy small craft and buildings and structures. Well, weak structures close to the shoreline, and you would hear us putting out yellow levels for long period swells, as the case may be. Another hazard I'd mentioned before is the dust. The dust season starts in the northern hemisphere just around the end of our dry season in April, and we see the increase in severity and frequency of those dust periods. And of course, people, when it becomes severe, even those who do not normally have respiratory ailments tend to suffer a little bit of breathing concerns. And it is known, a study has been done some years ago out of Barbados, correlating the dust with the increase in hospital attendance seeking assistance for respiratory ailments. I have read that paper a couple of years ago, so I don't have the details on it, but I know that they would have done that type of studies. And we know from anecdotal evidence, if you could call it that people tend to visit the hospitals a little more when these dust outbreaks are occurring. As I said, even if you don't have any major respiratory ailment, all of us tend to feel it when it gets this heavy. This is 3 month seasonal average number of dust days. Like everything in the northern hemisphere, when the sun begins to transfer apparent movement from the south to the north, everything tends to wake up because the winter in the northern hemisphere goes out and everything tends to wake up. So all the activities that happens over the Saharan desert, the wind activities begin March, April, May, and you see a rise in the Saharan dust over the years for those 3 month periods. The highest being May, June, July. So around June, we would have the highest incidence of dust, stronger dust days periods and increased dust days periods. So we're looking at our next one, very similar, but the monthly distribution of the dust days over a long period of time, and we see within June. So while we are in May at the end of June, and we are now right in the middle today, in the middle of a serious outbreak, very significant dust amounts in the atmosphere. At this time, in fact, I had made a prediction a few days ago about the rainfall, but it had been contending with the dust. And in the atmosphere, there's a balance taking place all the time, and the stronger ones tends to win out. So while the atmosphere may have been a bit unstable, and we had showers happening, it would not have been extensive, or it could not have developed extensively because of that dust in the atmosphere, which it is trying to contend with. So the forecast wasn't as accurate as I thought it would have been. So, but we know it's because of the dust. And also, as I said, as the sun comes into the northern hemisphere, we see everything waking up. So as the sun crosses our latitude for the first time around May, June, around from April, May, June, anytime like that, the records show that is the time when this band of intense insolation or incident radiation from the sun on the Earth's surface crosses our latitude, and we see the temperatures have a spike at the beginning of the heat season, and it continues throughout and it levels off during the middle of the rainy season. But there's another spike coming around September, and the sun travels southward again. So that is what this is representing here. The sun moving from north to south, and again from south to north, and again from north to south. So at the end of the dry season, we could see some heat peaks taking place. So that is one of the hazards of the dry season also. So what I would call, to summarize the dry season, we have high winds, which could cause structural damages to different types of structures and different strengths to availability to the wind. But the wind, we have had to send out yellow levels for high wind events in the dry season. We have rough seas, which could be dangerous for a lot of people who mariners and anybody who has to operate within the sea. We have long period swells, which become very dangerous as it approaches the coastline and really crashes severely against the northern exposed coastlines and have been known to cause severe damage to structures. We also have individual isolated thunderstorms. One thing we must be concerned of is that the thunderstorms, so on the instability of the atmosphere, don't just go away because it is dry season. So there are times, even one time in April, we have had severe flooding with many, a couple hundred percentage points of the long-term averages. So we could have some serious bouts, short-term bouts of areas of flooding in the dry season. And of course, I spoke about the heat peaks around April and May, the first heat peak. And of course, one of the major ones is the Saharan dust outbreaks for us. Of course, the drying areas, we have had years with severe fires and of course, destroy a lot of the land areas. So these are mainly some of the areas that you could look at for effects of the dry season as far as the weather is concerned, and negative impacts on lives, livelihood, and properties. And that is mostly it for the dry season. So before I go into the rainy season, are there any questions at this time that one might like to take a pause, that I would take a pause to listen to at this time?
Yeah, okay, so we have been getting a couple of questions indeed. So let's go at one of the questions so far. And by the way, for persons who have just joined us, welcome. And if you would like to know how to pose questions, you can do so in the YouTube chat. We will do our best to monitor there. However, the best way would be to send an SMS text message or WhatsApp message to the number 1-868-74-REACT. Again, 1-868-74-REACT. react. And that translates to 747-3228. Again, 747-3228. That's the number to WhatsApp or send an SMS text message with your question. So the first question we have here is, this is via Instagram actually. It's, what about chemtrails and whatever it is that they are using to block the sun and cloud seed that creates bad flooding? So I'll just repeat that. What about the chemtrails and whatever it is that they're using to block the sun and cloud seed that creates bad flooding? Over to you, Dega.
Well, Robbie, I don't think I can answer the question concerning chemtrails or chemical trails, but what I know, the trails we see in the atmosphere coming out from aircraft, we see an aircraft going across the sky. It is in fact the exhaust from the aircraft, and it is comprised mostly of water vapor. And because of the height of the aircraft in the atmosphere up there is very cold, it tends to form ice clouds, and it would remain in the atmosphere for quite a while before it dissipates. So people would see these streaks of, in fact, you would actually notice it forming while a high-level aircraft is passing. And that is what I know about the condensation trails. As far as chemtrails, I have no answer for that.
Okay, excellent. Indeed. So question about chemtrails, probably what they mean, contrails. Yeah, okay, so thanks a lot for that answer. I guess I know you have a packed presentation there, so you can continue, and when you're ready for other questions as they come in, we will simply pose them. So thanks so much. Excellent presentation thus far, Gary. Back to you.
Okay. All right, so I'll continue with the other part of the presentation, which is the wet season, hurricane season, weather systems. It is much longer than the dry season one. I would have presented it before, but I hope to give a wider audience more detail. First of all, let me start off by saying it is not really rainfall amounts that herald the start of our rainy season, but rather it is the type of weather system which produces the precipitation which is considered. So the weather systems we look at to the rainy season weather system, so to speak, are ITCZ, is the ITCZ, tropical waves, tropical cyclones, potential tropical cyclones, and individual thunderstorm activity development, building blocks of tropical storms, that is the individual thunderstorms on the micro scale and meso scale. And I have written a paper on the individual thunderstorms, and I've coined the phrase the Polari effect, because it is I was looking at it from a local point of view, and it has been published in the publication the Varisian, and you can see the HTTPS citing on it on, if you go to page 25 for the Varisian Guide, VARYSIANGUIDE 2025, at page 44 you will see a condensed version of that paper I wrote, which I finished in 2020, and coined the phrase the polar effect. And that should give you some idea of the development. But we cannot forget the continuation. So in the coming to the end of the rainy season, we have the second peak, usually around September. It short seasons. Some people would colloquially call it heat waves, but like, that is it in a nutshell. But let me go on to break it down individually. We first speak of the ITCZ, these trade winds from the southern hemisphere and the northern hemisphere meet, and when they come together, there is lifting, and we see cloud development, convective development, mostly around the globe. We see a rise band, making a band approximately around activity. Before is that as the seasons change, and it is closer to the equator, the ITC, one of our longest producers, is fairly active. It tends to last for hours or a couple floodings And it could bring, because of the cumulative effects and the elongated periods of rainfall, it could bring different types of flooding, one of which could be riverine flooding, which is fairly dangerous. And we usually send out different alerts and warnings for those types of events. As we go further on, leaving the ITCZ, of course, the ITCZ is made up of individual thunderstorms and elongated band, and you could imagine that passing over your area, your island, Trinidad and Tobago, for a couple of days, it would have that tendency even to increase the possibility for landslips and landslides and all the attendant effects of consistent and continuous moderate showers or rain. We move on to tropical waves. And I make the distinction between tropical waves being the ones we're looking at are the African easterly waves coming out of the Middle Africa, how, where, and when. Because there are different schools of thought with the waves. Once there's a traveling wave trough, some people tend to call it waves, moving from the eastern areas to the western areas. So I am focusing on the African easterly waves out of Africa, which are the main ones which we tend to look at. The others probably could come within the ICCZ and are caught up in the ITCZ and tend to be recorded as such at times. So tropical waves are generally batches of energy coming out of the African continent, and they tend to develop because of the contrast between the warmer air over the Sahara and the much cooler air over the sub-Saharan areas. And they would form in such a way very similar to what how jet streams are formed. And I'll explain that in a little while. So this contrast has the air, because of the higher air, the expanded air, warmer expanded air over the Sahara, and the cooler, more compressed air over the sub-Saharan areas. The air flows over from north to south over these, and in between that area, you have these African easterly jets being formed. And this is a graphic showing how a jet stream is formed, the polar jet and the subtropical jet. But those jet streams usually move from west to east or from left to right, more in the subtropical areas, just to the edge of the Hadley cells and the Farrell cells. And when the air flows over, because in the upper atmosphere, in the surface, I showed you isobaric analysis, which is pressure at the bottom of the atmosphere. As we go up into the atmosphere and we look to measure different states of the atmosphere, we look at what is called geopotential heights, or the height of the air to the top of the air column. And some air columns would be higher than others. So as the air flows over, in this picture from the subtropical jet into between the polar jet, it tends to tumble over, and the Coriolis force would take it and turn it right until it comes into a geostrophic balance and then flows out to the right. And that means if it is going from south to north and you turn right, it means that you will be going towards the east. But with the African easterly jet, you would not be going from south to north as in the polar jets and the subtropical jet, but you will be going from north to south. So when the Coriolis force takes over and turns you right, that means the air column in geostrophic balance and in waves, pulses of energy, would be turning towards the Atlantic, turning right towards the Atlantic, because it is total reverse in this area. And that is how the jets, the formation of the tropical wave starts over the desert. And we see a depiction of the subtropical high pressure and the cooler lower areas. We see how the African easterly jet forms in waves and heads out over the far eastern Atlantic Ocean. And we tend to see these developments of cloud patterns happening over Africa, Central Africa, just south of the sub-Saharan area. We see them developing, and as they develop, they tend to push these areas of cloud patterns and waves across the Atlantic Ocean, and will pick up even more moist air over the ocean and tend to develop. So let me go further. So we see these waves coming across the African area. Incidentally, everything, the winds and everything that would also be helping and pushing the Saharan dust is all part of the system. So it tends to lift the dust over the into the atmosphere, into what we call the Saharan air layer, and coming across the Atlantic. So these are two phenomena that tend to fight for position in the atmosphere, and tend to, one would win out on the other depending on their strength in relation to each other. So the tracking area for the tropical waves are usually on the equatorial side, because it is moving from eastern tropical Atlantic towards the western tropical Atlantic on the equator side of the high pressure cell. Everything comes out of the high pressure cell. All the energy is stored in the high pressure cell and spirals outward. And the tropical waves are caught up in this steering pattern and come straight across the Trinidad and Tobago and the Lesser Antilles. Depending on the shape of the high pressure cells, if they are integrated or broken up, you will see the waves following the least resistance, and some may go north before reaching us, and some may cross the Caribbean islands, the Eastern Caribbean, and produce weather across us. The shape of the tropical wave is, in fact, it looks like an inverted V, an inverted U. It looks like a wave in shape as it crosses across the islands, and this is a depiction of how it might shape. Now, the orange part of the wave you see in there, depicted in this graphic, is the axis. A wave is a synoptic event. So there's the axis. A lot of people talk about the wave as just the axis alone. The wave is not a thin line. So we have, before the axis, we have certain types of divergence, sometimes convergence, how the wave is developed in the upper atmosphere as they go from the ground upwards, how it leans from north to south meridionally, how it develops in the upper atmosphere. There will be different developments and convergences on different points of the wave. The orange line is just the axis, and we usually have following a higher bit of convergence on the trailing part of the wave, which is after the axis. So when we talk in terms of a tropical wave, some people talk in terms of the axis alone, but the wave is a wide synoptic system that has a front part, back part, and the axis just on the peak of the wave. So they travel across the Atlantic, as I said before, guided by the Bermuda North Atlantic, Bermuda Azores subtropical high. It is along the equatorial side as the guiding position from east to west. And we have approximately, don't hold me to those numbers exactly, but we have approximately 60 to 65 waves approaching us per year. And of course, because of that amount, we should, within a 6-month period, we should be experiencing some of the activities for those waves. The frequency peaks around July and August, because the highest contrast between the temperatures of which I spoke about earlier, the hot Saharan desert and the cooler sub-Saharan areas, the highest contrast and difference in heights of those air masses is around July, August. And at that time, we'll have about 10 tropical waves approximately rolling off from the African continent per month. So 10 into 30 days, probably every 3 days. But it's not an exact event. It depends on the climatology of the year and things like that. As we say, in July to August, we have the higher incidence of the tropical wave rolling off the African continent per month. This is a surface analysis again, showing the tropical waves as they move across. They tend to cross the Eastern Caribbean and tend to go out into the Caribbean Sea, and some continue onto the Pacific Ocean. Now, this is a U.S. National Weather Service analysis, and some waves you will find we have different numbers at times because some waves will be depicted along the ITCZ. And as I said before I started this put back, we're talking about the African easterly waves. So we see the depiction of the tropical waves as they enter into the Eastern Caribbean and also leaving the Eastern Caribbean into the Caribbean Sea. I have marked off in the cloud patterns, which you could see I have marked off 3 areas of tropical wave activity. And you could see the shape of the cloud pattern, the cloud signature, where the waves are with those light orange colors. You will see where the waves are occurring. And to the bottom, you see some ITCZ in between. But the waves are definitely seen a wave-like pattern along the equatorial side and approaching Trinidad and the Eastern Caribbean. This one is depicting just east of Trinidad and Tobago. As you see the ITCZ trailing into a very strong tropical wave. And tropical waves, it is almost at this point as if it wants to form into a cyclone, because tropical waves are the seeds for cyclonic development or cyclonic activity. So tropical waves, besides bringing weather, are seeds for tropical storm development. So we tropical cyclone development. So we look at it very closely. So when we see a tropical wave, it usually has an area of disturbance somewhere along the axis and could form into a low pressure area and eventually a cyclone. So we have to be very careful with the development of tropical waves as they approach. But not all tropical waves will give you extensive weather. Some will come and for Trinidad and Tobago, while we say that a tropical wave is approaching, and the population might say, well, they predicted a tropical wave and nothing is happening. It depends on the tropical wave itself and the development as it takes place along the wave, and sometimes the wave passes and it misses Trinidad and it hops over Trinidad, hits somewhere in the central island. And we may then, after 24 hours, experience the trailing convergence of the wave. This depiction shows a wave developing, a stronger and stronger waves until it comes into a cyclone and possible hurricane as it moves forward. As I said, not every tropical wave deserves a name. We start giving cyclones a name when it becomes tropical storm intensity. So there isn't always any need to panic when we hear about tropical waves, but there is need to have a heightened attention to the weather that is going on around it. So the tropical wave may approach you, and it would affect Trinidad and Tobago in different levels. So when you hear things like tropical waves approaching, it is incumbent upon you to have a heightened awareness of the developments of the weather pattern, and of course, you should go on to always look at the day-to-day forecast, or if any information or alerts is coming out of the Trinidad and Tobago Met Services. As I said, some waves could be weak, some waves could be stronger, some waves could pull up the ITCZ, trailing with it, and cause severe weather at times. So there's a variation of activity that could occur with tropical waves. So we go on to tropical cyclones. Now, tropical cyclones are made, well, how, where, and when, we'll talk about that. And also we talk about potential tropical cyclones. So a tropical cyclone is a non-frontal cyclone. That means turning counterclockwise in the northern hemisphere of a synoptic scale, developing over tropical or subtropical waters, having a defined organized surface circulation. And these include in our parts of the Atlantic, these include depression, storms, and hurricanes. These are all cyclones. And the potential tropical cyclone is a disturbance that has not yet um, formed into an actual cyclone. But in order to give the reporting procedures a chance, so that because we suspect it may become a cyclone soon and hit land areas. So if we don't have the designation tropical cyclone, we cannot predict a cyclone as yet until it's probably too late or too close. So the advisories for potential tropical cyclone can now be issued up to 72 hours before. It is again a disturbance that is not yet a tropical cyclone, but which poses the threat of bringing tropical cyclone activity, either tropical storm activity or hurricane condition, to land areas. And as I said, they could begin to issue advisories for that 72 hours in advance. So give ourselves enough chance for preparation in the event that it could develop into a cyclone. What is necessary for cyclones? I use 5 here. Some people have 8, some people have 5, some people have 6 or 7. But the basic ingredients for the development of a tropical cyclone, you must have a warm sea surface. And when I say sea surface, not just the thin surface, but to certain depths, well mixed, to give a warm sea top, if you like, so that it would have enough energy in the top of that waters to the developing system could feed off and begin to grow and extend. We need the presence of the Coriolis force enough to create cyclonic turning. That is why cyclones partly forms within very close to the equator, but within the changing times, I've seen in 2017, a couple came across when I was in Tobago. I think it was Don and Brett. But we need, the idea is it needs the Coriolis force. And the further you move away from the equator, the stronger the Coriolis force. So that is that fine line just away from the equator and not too far into the cold waters, away from the equator, but into the warm waters. Ideal conditions for the development of cyclonic activity or disturbances. You need in the vertical small wind shear or small variations in the wind speed as you go upward, because you don't want harsh variations in the wind speed and direction, because it would tend to blow up and cut off the tops as they develop. You also need a pre-existing area of disturbance, either a weak low pressure area or low level cyclonic circulation, and it starts to develop from there in the pre-existing disturbance. Throughout the year, you would see Miami and putting up touch areas of disturbance and also along tropical waves, because those are the areas most likely for the tropical cyclones to develop. And of course, you need an exhaust system. In the upper atmosphere, you need divergence above the system, or what we call outflow. Just above the system, it would be cyclonic, but to the side of it, and without getting into too much of the meteorology, you have anticyclonic outflow. So you need that divergence happening to keep pulling from the surface, much like a straw. When you're drinking from a straw, you pull the atmosphere from above the straw, and therefore the pressure, what is happening within the can, pushes the liquid up into the atmosphere. It is the very same physics that causing the cyclone to continue to develop. So as long as you're able to suck that atmosphere out, then you would have atmosphere moving up, further up and developing. This is just some areas. I didn't want to get too much in depth into the science, but we could still look at how it operates. The air would normally flow from high pressure to low pressure, just like I explained in the upper atmosphere with the tropical waves. This is on the surface with an isobaric analysis. It moves from high pressure to low pressure. But as it moves from the high pressure to low pressure, it is influenced by the Coriolis force, which tends to turn it to the right. And as the Coriolis force and the pressure gradient wind becomes balanced, it is called what is called a geostrophic flow, which flows directly in line with the isobars. But of course, at the surface, there is what we call friction, and the friction will tend to throw that balance of filter and tend to push that flowing air further inward into the low pressure in a cyclonic or counterclockwise in the northern hemisphere way into the low pressure system. And we see it here happening as the air comes from the ground around the low pressure system. It is pushed into the low pressure system. And if there is upper level diffluence and full outflow and convergence of the surface, but more and more upper level outflow, and the pressure drops within short distances, then the wind speed will tend to increase because you have a higher pressure change within a shorter distance. And the more and more outflow takes place, more and more the disturbance develops into a cyclone, and stronger the cyclone gets. As we said, it goes into areas that are conducive for cyclonic development. We have strong upper level outflow and the warm sea surface temperatures and little shade. And this is how they predict how the hurricane or the storm cyclone would develop into a hurricane or stronger, depending on its steering column, which I spoke about earlier, steering area, and where it is going to see if it will diminish or increase in intensity. And the main parts of the hurricane, of a tropical storm or tropical cyclone system, but I will go to immediately to the hurricane because those are the main parts. And it has to be a strong hurricane to have an eye. So you have rain bands, the eye, and the eye wall. Or the eye wall is this, incidentally, is the areas, the most powerful thunderstorm developments. And within the rain bands, what we call feeder bands, there are spaces or modes where the air is sinking and warming air is occurring similar to the eye. So everything that goes up, some of it would come down. I remember a hurricane, I can't remember the name of it right now, it slips me. But after that hurricane, people were complaining in Louisiana, I think it was, of the extensive heat. That is because what went up in the air was coming down and it was having compressional heating. And therefore, a lot of people, unfortunately would have passed in the days after the hurricane because they were stuck in attics and on roofs and had to bear, according to their constituency, according to their body's abilities, some of the older people and the very young, they would not have been able to take the difference in temperature and that excessive moist heat. So the air spirals in toward the center in a counterclockwise pattern in the northern hemisphere and clockwise in the southern hemisphere, and out the top in the opposite direction or an anticyclonic outflow. And these are depictions showing in the thunderstorm areas or the eye areas or the bands of thunderstorms, you see the air rising updrafts in the thunderstorms, and as it goes up, it tends to get cool in the upper atmosphere, and some would go to the outflow, and some would cool air. It would descend, it would sink, and as it sinks through the eye, there is what I said is compressional heating in the atmosphere. So the eye is a clear area, no cloud development, and could be a little warmer in certain areas. We see another depiction of it with the air. Some of the blue air that is on the top gets cool and it goes out into the outflow. But some of the air comes back down into the eye and allows for clear spaces in the eye. And this happens when the cyclone becomes very strong and therefore an eye is formed. In storms and depressions, it is not strong enough to show an eye. This is another picture showing the internal spiral, and it isn't too well depicted here, but this is a visible picture from the above of the cyclone, and we can see the mass of a hurricane. It is in fact a hurricane because we are seeing the eye, we are seeing the eye wall, the raised cloud patterns, even with shadowing to the left of the center of the picture. The clouds are so tall that they're casting shadows on the other clouds. And when you look out in the extent, you could see the horizon, far away in the horizon, and probably if you look good enough, you can see a curvature of the Earth because this is taken from the satellite. So we see the cyclone It's a large area, and within that area, closer to the eye and the eye wall, there, if it is a well-developed hurricane, you would find that there is a certain distance outward, calm eye, and then from the eye wall, a certain distance outward, you will have hurricane force winds, and as you go further outward, you would have storm force winds, and then you would have feeder bands. So if a hurricane is approaching one island to the north of Trinidad and Tobago, and we see that the extent of the hurricane force wind is further north than Tobago, Tobago may not, or Trinidad may not come under a hurricane watch or warning, but with the same system, we could still come under a storm watch or storm warning, because the part of the system that passes us is generating storm force activity. And we see this is Dorian. I don't know if much people remember Dorian, but Dorian sat over the Bahamas for a few days and causes some devastation. But this is where we had a visible aspect of the cyclone. And the last picture, this is another hurricane called Dorian. And we could see the eye wall, which is greens and the whites, going further up in the scale, the temperature depiction scale. Around that, you see the darker reds, which may most likely be hurricane force. And as you go out, when the reds get a little lighter and a little more into greens, where you might get storm force. You also have off to the right-hand side of the storm as it moves. It was still there, but it was looking to head northward. So on the right-hand side, you see some in the rain bands, some serious weather taking place. So even in the rain bands, you can have severe weather with strong downdrafts momentarily into storm force and could cause sometimes as much destruction closer to the center of the cyclone. So the cyclone has stages of development. As we go into the stages, the weakest tropical cyclones and depressions, where they are less than or equal to 38 miles per hour or 33 knots. As it intensifies and its maximum sustained winds goes between 39 to 73 miles per hour or 34 to 63 knots, it is designated a tropical storm, and it is then given a name. And as the cyclone sustained wind speed was further 74 miles per hour or above, it is now designated a hurricane. And hurricanes are even further designated into different wind speeds categories, from category 1 to category 5. Category 1 is 74 to 95 miles per hour. Category 2, 96 to 110. Category 3, 111 to 129. 4, 130 to 156. And above 156 for 157. And above we have category 5. When you hit category 3, it means then that it is a major hurricane. So category 3 and above, a major hurricane. And this is not other areas showing what the wind speeds can do. Different graphics, damage to landfall. Now we went to category 1 to 5, and some people ask the question, why not have a category 6? Well, at first, the designations 1 to 5 were really looking at the type of destructive power of the wind as far as the wind speed destruction and the storm surge is concerned. And it was felt that after category 5, there was nothing more left to destroy. So category 5 would have been that wind strength and above. But we have found in later times that we have been seeing stronger and stronger cyclones. So if only to give a designation for the wind, I don't think there's any harm in giving a higher category, because it's a designator to point out the strength, especially with the possibility of these effects in climate change. But the fact of the matter is that depending on a building's structural integrity and its codes and the proximity to the water bodies, category 1 to 5 could give you some depiction of what the wind speed and the hurricane effects are likely to have in your areas. This is a general idea of the kind of destructive properties. Of course, if the building's structural integrity are not sound, this goes out the window and a category 1 could do severe damage. So this is dependent on strong building codes and proximity to bodies of water. In the hurricane season, which is tomorrow, begins tomorrow from June the 1st to November the 30th, we see these is areas in red, which shows where the tropical cyclones and the patterns are most likely to form. And we are most concerned with the area there, just north of South America, within the Atlantic Basin, west of Africa, and going up the St. Lawrence, what I call the St. Lawrence Gap. I hope Bobby does forgive me for calling it the St. Lawrence Gap. But the warm waters of the hurricane cyclones can form there, not form there, can follow that path and become extratropical. So those are the areas where most likely for the formation of tropical cyclones for us are concerned. Now, although I know I would like to speak on the effects of these storms, but it all boils down to the individual thunderstorms, how, where, and when. Or everything that I've spoken about earlier on would have been based on thunderstorm activity coming into some formation. So individual thunderstorms are, in fact, the building blocks for tropical cyclones, tropical waves, and other areas of disturbance. The thunderstorms can occur individually, at any time of day or night and in any season when the atmospheric conditions are right. They are usually on microscale development, which might not trigger a common alerting protocol for Trinidad and Tobago, a CAP, may not trigger a yellow level. But because it is so small, it can still be very impactful to persons and properties in smaller areas. So we have heard of even tornadoes, small, short-lasting tornadoes out of the thunderstorms that have affected one village, and within a short space of time. No cap was put out for that because it was so small and the impact was not expected to be large. But for the persons involved, it was in fact a tragedy. So these thunderstorms, what are the main ingredients? For the thunderstorms to form, must be looking for moisture, preferably in the mid to lower levels of the atmosphere. So you can have some connectivity in the development as it go to low to mid level, and then continuing to develop into the higher levels and form these deep convective clouds. We also look for instability, or that is for the air to be able to rise and accelerate upward, for the air to move vertically upward or downward as it started. If the air is stable, it means the air would have a tendency, if pushed in any way or acted upon, it would have a tendency to revert to the position it was in. But in unstable air, if it is pushed in one direction, it would have a tendency to continue on in that direction unless acted upon by some other force to slow it down or to continue it to speed up. And also we have the lifting agent of this warm, moist, unstable air, which could be orographic lift, mountainous areas. It could be the convergence, as in the ITCZ. It could be convergence along different parts of a tropical wave. It could be convergence in a disturbed area that has have some outflow above it and developing it into a cyclone. So the tropical storms are, again, are the individual building blocks of all these weather systems. The stages and life of a thunderstorm, the life cycle, the lead times possibly as low as 10 minutes, and the life cycle approximately 45 minutes to 1 hour. Now you can understand that while we may talk about thunderstorms tomorrow, we may not always know exactly on what village where the thunderstorm might develop. And also we see at times thunderstorms develop and persons in different media and the population very concerned, very understandably concerned, are saying, what is the Met Office doing? Or we only putting out a yellow label when the thunderstorm occurs. But you must understand the lead times for the smaller scale activities. It's as low as 10 minutes, and by the time you draft a yellow label, within 45 minutes to an hour, it does all its destruction and stops. As a comparison, tornadoes signals are sent out sometimes as low as half an hour, 20 minutes before an actual tornado occurs. But there will be the forecasting of the possibility of tornadoes. In the same way in Trinidad, there's the forecasting of the possibility of thunderstorms. We have a picture of a thunderstorm here, an individual thunderstorm, where you're seeing clear skies all around, and just under that thunderstorm, under that white mass to the surface, you can have severe weather taking place and flooding. And the area is not large as the whole of Trinidad and Tobago, but it is extensive enough to cause severe flooding and serious impacts for the person under the thunderstorm. We also look, this is taken from Piaco, we look at one there. You see those gray streaks or that gray colored area that is closer to the land, to the horizon. That is where the heavier precipitation is taking place. That is the angle at the top that is very high, catching the sunlight, and there's much disruptive power in the torrential rainfall in the short space of time, and also the lightning discharges. So what you could look out for in very short space of time in the individual thunderstorms is floodings and things like that. Flooding, river rain, not river rain so much in this case, but you have street or flash floodings taking place, landslips or landslides taking place in a very short space of time. So what are we to do when we hear about thunderstorms? Well, some local weather impacts for individual thunderstorms. Weather effects, heavy showers, strong downdrafts, lightning, thunder. We also have funnel clouds, that is beginning of tornadoes that hasn't yet reached the ground. We have water spouts, which are tornadoes over the water, and we have actual tornadoes at times over land. Although the tornadoes in our areas may be very short-lived and weak in comparison to the tornadoes in other countries, but they still pose a threat and cause some type of destruction in the short space of time they occur. What are the impacts? Floodings, flash street, possibly river rain. If we have a number of thunderstorms developing and continuing over an extended period, most likely those thunderstorms will be in a system such as the ITCZ, a tropical wave, a disturbance. And we have electrical discharge and damage to the property because of the electrical discharge. You also would have landslips and landslide. Possibly as much damage as a synoptic scale storm or weather event, but on a much smaller scale, especially if it develops in clusters. So you can understand that there is no yellow label out, there is no storm watch or storm warning or system approaching, but an individual thunderstorm developing a small scale in your area. You could have loss of livestock, pets, furniture, appliances, destruction or disturbance to life and livelihood. So as I said, there might not be a trigger for a cap alert, but it can still be devastating to individuals in small areas. So my advice is to take seriously any forecast that forecast the probability of thunderstorm development in your area. Note that, take seriously. Do not wait on a yellow level. If you know your area is likely to flood and they say a thunderstorm is likely to develop over central Trinidad and you're living in central Trinidad, do not wait on a yellow level and come on the media and saying, what is the Met Office doing? You must prepare yourself for the eventuality of a small, very powerful, small in space and time, but very powerful, that could have caused destructive events to your area. And again, I invite you to look at the Varisian guide, VARYSIANGUIDE, 2025 on page 44, you would read a condensed version of the polari effect that I had written about, and would give you a more in-depth idea of how these thunderstorms tend to develop over Trinidad, especially over Trinidad, mostly over Trinidad. Some people call it East Coast convergence, but I write the paper with the view. For the layperson, it was not an academic paper. It was written for the layperson to understand how the systems, most likely, in my opinion, likely to develop and cause certain types of destructive activity. And this here is an area where we had put out a cap for, and these are clusters of thunderstorms. I did a depiction on this type of infrared to try to show up more, but it captures clusters of thunderstorm, one just over the southeast of Trinidad and two further south over the mainland. Now, we did in fact issue a yellow level for this, and we did have some severe weather in the southeast of Trinidad because we had issued a cap for Trinidad and Tobago for that. But there were people in the north and northeast and northwest who were saying that the Met Office didn't need to pull out a cap. Okay? But yes, we did. Because although it wasn't expensive to meet your area, when you're thinking in terms of the weather, spare thought for the persons who may be experiencing the weather. And stop. It is not, you have to have an overview of what exactly is happening. And I remember that night I took those pictures, and because it is part of my job, and I was looking to see the developments taking place. And that says 1 to Z, that is 9:30 in the night. And I was looking to see the development because I was very concerned. And we already had a yellow level out. So yes, the yellow level was warranted. And yes, we did have severe weather, even though parts of Trinidad were saying that, but unknown with their limited information, was saying that Trinidad we should not have put out a yellow level because we had severe weather in southeastern parts of Trinidad. And it was close enough on the southwestern peninsula near the Icacos, where we see the severe weather just touching the tips the southwestern peninsula of Trinidad. This is another depiction where we did not put out a cap because the weather we were looking at, those yellows to the east and the offshore areas, was, to put it simply, was not expected to have much impact. And it was like if it was going to be normal rainy season weather, because this is in November where we expect that type of rainfall, and we're not expecting to have any severe impacts. So there was not a cap that day. And at about 2 o'clock, I get the time exact, about 18:20 or 20 past 2, I took the picture, but about 2 o'clock, because of the orographic assistance, 2 individual balls of thunderstorm activity developed over the northern range and the foothills. And Crystal Stream, we would have seen last year, we would have seen all the effects and damages that people would have had to clean up after the river would have overflowed. And within 1 hour to 2 hours time, it was cleared and nothing else happened. So this is what I'm trying to get at, is that the destructive power of the individual thunderstorms, whether we have a cap, a commonality protocol on. So once you hear the possibility of thunderstorms, even over your area, take it seriously and don't wait until a cap is put out, a yellow level or whatever have you. Because the yellow level is very expensive, and there are different levels to the yellow level. If you look at the matrix, I don't have a picture of the matrix right now, you would see sometimes the yellow level is upgraded, but it remains yellow, because we are saying that while we were predicting it, it is now occurring and we have an upgrade date. So the certainty increases and or the impacts may increase. So I want to stress again, all these systems that affect us are made up of individual thunderstorms. And we have to be very careful with that. While we could catch the synoptic events days in advance as they come up, we see tropical wave development and potential for tropical cyclone development. We see disturbances. We see the ITCZ. So while we could predict those in days in advance and put out yellow levels or orange levels, as the case may be, God forbid, we don't want to put out any red anytime, but we could see it, and if we go back to Beryl last year, we could see the Met Office working in a way that had the country informed, the red for Tobago, orange for Trinidad, because this was a synoptic system that was approaching and developing, and we had enough lead time to develop our predictions and forecasts and our alerting protocols, warnings and things like that. So because it was a synoptic system with more lead time. So the individual thunderstorms sometimes don't give us enough lead time. Sometimes by the time you look to draft a yellow label, the area is so small and also the time is so short that it is occurring. Somebody in Central is experiencing distress due to a thunderstorm, and they are saying they are not seeing any yellow level. And other people are saying what they're making fuss about is just rainy season. But when you are in the weather, for those who are not being affected by the weather, please stay a thought for those who are being affected. And everywhere in Trinidad and Tobago, we are neighbors, and we may at some point in time not experiencing bad weather, but we may be called upon disaster management unit to help our neighbors and to send resources and supplies. So spare a thought for the people who can be affected in small areas across Trinidad and Tobago. So we go on to tracking the tropics. Robbie, you want to pose any question now, or we could continue?
All right, so again, a reminder to persons who would like to pose any questions. You can do so either via SMS text message or via WhatsApp to the number 1-868-74-REACT. That is 1-868-74-REACT. And we know we have a couple persons up the Caribbean as well, so feel free. You can WhatsApp us or SMS text us. That number, by the way, 74-REACT, works out to 747-3228. Again, it's 747-3228. So feel free. All right. So we actually have quite a few questions here, Gary. So I guess we could take them quickly. So Aman asks, good night. I was wondering if there were tornadoes in the past in Trinidad and Tobago.
Yes, we do have tornadoes in Trinidad and Tobago. We have regular water spouts, which are tornadoes over the water. Anybody who works in the Gulf of Paria, who works in any area, in those areas, would, even before I was into meteorology, when I was much younger, I have had known people who used to go to dive and to work in the Gulf of Paria, and they would have talked about this phenomenon called water spouts. Only when I understand the weather a little better now, to know that there are tornadoes over the water. We also have heavy downdraft microbursts, which could be mistaken for tornadoes, which are very destructive on the land, but the pattern is different. When the microbursts would have a radiative pattern as it comes out from the cloud, the tornadoes have a sort of elongated track as it touches down. So yes, we have seen those tracks. I think there's a place called Manahambre Road that we have had reports of tornadoes. There's a very funny video a long time ago about a certain person they were looking for because of the tornado, and they were filming the actual event and be very excited about it in that time. So yes, we do have tornadoes, but most times they are very short-lived, and thank God they are short-lived. And yes, they are very much smaller than the mid-latitudes tornadoes in the USA and places like that, but they do cause roofs to be blown off. And part of the reason for that is because the roofs sometimes are not well put together so that any strong wind could blow them off. But tornadoes, yes, we have them of a certain strength and short-lived and could cause destruction to the weaker structures.
Okay. All right. So thanks for that response. And another question, Joshua asks, Do you plan to install more weather stations in Trinidad and Tobago in the near future?
Yes, there are plans to install more weather station as we speak, but there are certain what's the word I'm looking for? There are certain aspects to the installation of it that are beyond the science of meteorology or the meteorologist. This is more administrative, and things have to develop in such a way. One of the things that could keep us back is the security of the weather stations and where we could put them, so that it makes no sense we put in 20 weather stations and we lost all in the nighttime due to people stealing them or taking parts from them. So we have to find ways and means of putting it together like that. The administrative process has to take place. We of course, we like a more dense network. It would help us greatly, especially for nowcasting. We have some areas where we could draw information from different agencies. There are areas we could draw information on river levels. We could draw information on different water resources agencies at times. But if we have our own weather stations with a denser network, the people who are trained to observe the weather can make reports on it. We use the radar. Sometimes I personally would use the radar, and I see approaching thunderstorms. I think the thunderstorms will sustain as they cross the land. Then I might put out a social media a bit of information to alert people onto what is happening. So yes, we have plans and we are trying, and it takes some time. Some of them is in the testing phase, and also one of the ideas that it must be up to standard to be able to use it in research and things like that. It must be up to WMO worldwide standards. So we have to put all these things together, and I hope soon enough your question would be satisfied for me, both me and you and everybody else, with a denser, more robust network, because it helps all of us. It helps me to do my work, and it helps me to put out information to keep you safe.
Okay, excellent indeed. So we are getting questions fast and furious. So we'll just take a couple more that we already have recorded here. So Wazim asks, when will the TTMS implement an in-house high-resolution numerical weather prediction models?
Well, the numerical weather prediction models requires very powerful computing power. It costs a lot of money. We, on a smaller scale, have been having little conversations with the climatologists, and we've been producing very small scale models, but we have the availability of the worldwide, the ECMWF, the European model, and the North American models. So we have those and a few other models that are already in train and working very well for us, that we tend to be able to use. And I use them extensively. They are tools, because we still depend on the effectiveness and the skills and the knowledge of the forecaster. So yes, all these things are in train, but as I said, it is not a factor that the meteorologists themselves can control, but is rather an administrative factor, both for technology and financing. And we hope in the future that we can be seeing ways by the technology which we can develop it, but we need considerable financing and processing power.
Okay, great. Thanks, and let's go now. Grace says, if extreme rainfall events are caused by increasing atmospheric and ocean temperatures, which are projected to increase in the near future, and are largely out of our control as small island developing states, what can SIDS do, which is small island developing states, what can SIDS do to mitigate the effect of these extreme rainfall events, seeing as we cannot prevent them?
Well, the small island states, which includes Trinidad, may not be under the small island states, but we are not that big of a landmass in comparison to other areas of the world. We are part of the Eastern Caribbean. All the governments, all the persons involved in the administration, the running of those countries, have to get to the understanding that the weather is changing, and the meteorologists and climatologists are doing what they're supposed to do, and are warning and predicting of what is possible to happen. So it is left up to the individuals and the administration of each state and maybe CARICOM together and everybody else to be able to, because you now have the information to set developments and terrain. In other words, where we may want to build closer to the sea, to the seashore, we look forward to building more buildings, more inland and on higher ground. We have to increase our building codes, strengthen our building codes, and not, of course, cut corners on that. The initial cost would fall, but much more make up for the eventual effects that could happen. So you have to do certain things like that. You have to look at the possibility of losing beachfront and see if you can develop beachfront activities in different areas. So there's a number of things one could do and should start doing now that you have been forewarned and the climatologists are given the information, rise in sea level and things like that. So what can you do as an individual? Lobby to your the persons who are in charge and keep the question of climate change in the forefront, and let's see what we could take it from there.
All right, excellent indeed. And folks, speaking of climate change, we still have several slides to come. Of course, Gary has up there tracking the tropics. We also have the 2025 Atlantic hurricane season predictions, and along the lines of the question that was just asked, climate change and global warming. So more slides to come up, but let's see if we could take a couple more of these questions that were asked a little while ago. We'll take about maybe 3 or 4 more of them, and then we will go back into slides. We'll probably stop somewhere and take more questions again, and then we will continue. Okay, so Joshua asks, are there any plans to post climate data from PRCO and Crown Point more often regarding temperature and rainfall publicly?
Okay, we cannot post everything. We cannot push everything, so to speak, so that the more imminent information as far as weather and climate is concerned, the more upfront and shorter space lead times, we have to push that as far as outlooks, yellow levels, caps, we push that, but there's a lot of information that you have to pull. The onus is on you. Also, the Met Office doesn't have the resources to push to every individual one and tailor it particular for every single person. Otherwise, we would have to push 1 million pieces of information every day. So that we have a site called www.metoffice.gov.tt. And on that site, you will have all the information that you see posted on social media, that is posted on different types of media. And also there are other information. We have seasonal forecast. We just finished with the NCOF. You will find the information for the National Climate Outlook Forum on that site. You'll have radar. We have a dust index when it is working. We have agricultural forecast. We have the daily forecast. We have the 5-day forecast. We have 10-day forecast. We have 15-day forecast. We have the sub-seasonal forecast. We have the climate forecast. And if you go now on that site and you peruse it and you look for the information that you need, I am sure you will find some piece of information that will assist you in whatever endeavor you may have to carry out.
Okay. All right. Thanks, Gary. So moving on to the next question by Shastri. What is the role of the Bermuda Azores high in creating the high winds of our dry season?
The Bermuda Azores high is just between the Harley cell and the Faraday cell in the sinking areas. It moves and shifts differently depending on the season. As the sun moves southward of the equator, we would find that the Bermuda Azores high comes closer to us, and that is mainly in the winter of the northern hemisphere, and just about the ending of the winter into mainly most of our dry season. So we have this bit of high pressure, and this is mostly in the mid latitudes. And as I said, as the winter comes along, it is pushed further south. So we are closer to the outward flow from that high. Now, in the atmosphere, there is sinking air above that high. All the pressure is built up over that high. And that is why it is high pressure, because it's higher relative to the atmosphere around. And as it builds up, all, in a simple way to put it, all the air mass is pushed spirally out of a high pressure system. So a high pressure system is where the energy builds up, and a low pressure area, like a cyclone, is where the energy is released to the atmosphere. So the energy builds up in this high pressure system and is pushed clockwise spirally out of the high pressure cell. It comes equatorwards, and then it turns along the tropical areas. With all this energy, the closer it is to us, and because of the difference in the pressure gradient, we would have some stronger winds coming out on the equatorial side, and that is coming straight at the Eastern Caribbean. So that is the role it plays, and the high winds would whip up the seas, it would whip up moisture, it would whip up the waves, and that is why we call that time of the year kite flying season, because we have some heavy generation of heavy winds. So that is the role it plays. The energy is built up in the high pressure cell. It comes spirally out, and it flows towards on the equator side, towards the Eastern Caribbean, and give us some strong winds.
Okay, thanks a lot for that response. Let's take one more. Well, I guess it's a question or comment, and we have a few others, but we will queue those up and we'll get to you. So the next one, Jen makes a comment, says, I think a storm might move over Trinidad and Tobago this hurricane season. I'm so sure that a storm is coming that I had someone secure my roof today. Gary, you want to comment on that comment or question?
Well, my comment is this. As a meteorologist for so much years, we do predictions and not prophecies. Prophecies meaning that we are sure of the future, which none of us are. And predictions meaning that we base on mathematical computations and probabilities. So if you have a probability of 80% of chance of something happening, there is also the counter probability of 20% chance of it not happening. So the higher the probability, the more likely it is to happen. Good for you. Good for you. And I think everyone should take example from you, whether we know a storm related to Trinidad and Tobago or not. If that you secure your rope, just in case. And this is what all these forums are about, to keep you informed and that you would be well prepared. As far as the storm coming for Trinidad and Tobago, I, as a meteorologist, I look at the weather, and sometimes I would have to put myself out there on social media making predictions of the weather. Last Friday, I made a prediction because we had an approaching tropical wave. We also have a perturbation, which is darker today. And I said that the weather going to be very variable. And my prediction was correct. Okay, but a lot of people were thinking that tropical wave, bad weather. I think, but what was the winning factor was the dust, in fact. So we cannot always get it exactly right, but we can get it to a certain extent that would help you to be better prepared. And to be honest, sometimes when I see the type of weather out there that is just to the east of Trinidad and Tobago, sometimes when people sleeping and I 2, 3, 4 in the morning taking satellite pictures, I so hope that I am wrong. And when I am wrong, I just say give thanks that I am wrong. Nobody knows that I say that. But imagine you're doing a job and you hope to be wrong at doing it, because the type of destructive power that I am looking at out there, and no one is aware of. And I just pray sometimes that it doesn't come in land. And so far, we have been lucky. I don't want to go down the rabbit hole of what is actually, but we have been lucky. But we could take example from last year, what happened to us, and we have to be prepared. That's basically what it is. And whether we think a hurricane is going to hit us or not, or a storm, good for you. Everybody must follow your example.
Yes, yes, indeed. Thanks for that, Gary and Jen. Agreed. Always good to be prepared. So continue advocating. So, folks, we still have a couple slides to go. We have tracking the tropics as on your screen. We also have the 2025 Atlantic hurricane season predictions, and then also a bit on climate change and global warming. So we'll pause the questions, keep them coming. And for persons who would like to ask questions, we have quite a bit queued up, but feel free still. The number to send your text message, that's SMS text or WhatsApp messages, would be 1-868-74-REACT. Again, 1-868-74-REACT. That works out to 747-3228. Again, that's 747-3228. Keep the comments coming and questions and so on. And also, we are monitoring the YouTube chat as well. So if there are any comments or questions, we'll do our best. So we got you. But it's time for us to return to some of the slides and the theory that Gary is sharing, a wealth of information that I'm sure we are all learning something new and quite a volume as well. So let's continue with the presentation. Back to you there, Gary.
Okay, thanks. So we have to track the tropics because, of course, we are in the tropics, and we're looking at significant weather events that could cause destruction for us. And I keep using the word destruction because, yes, that is what it could cause. The impacts could be very severe for Trinidad and Tobago and the Caribbean, which we have experienced before. And we want to be prepared for it as much as possible. So this is a chart of all-time hurricane activity. The reds are the hurricane and tropic. No, the reds are hurricanes and tropical storms. We have a depiction of red and yellow. Basically, what it is saying is that September the 10th has been the highest incidence over time of hurricanes and storms, cyclones. And also, we see from June the 1st to November the 1st, the most incidences of hurricane. The peak, of course, is September the 10th. But we also see what is significant outside of November and outside of the beginning of June, before June and after November. We see some little yellows and some bench rain because it means then that hurricanes or cyclones have occurred out of the hurricane season. We have known it within recent years to occur. So, but this is the peak, and this is why we call June the 1st to November the 10th the hurricane season. We have what is called an area of interest. So this picture is depicting the whole North Atlantic hurricane basin, basically this region 4. But the area of interest, that white box that we're looking at there, is our area of interest because we have found that when cyclones or disturbances are looking to develop in that area, it poses a threat to Trinidad and Tobago and the Eastern Caribbean areas. In this area of interest from the climatological period from 1991 to 2020, we have the average per year of 4 named storms, and one of which go on to be a hurricane. So what information to look out for? We have the Climate Outlook Forum before every season, before the dry season and before the rainy season. And we had the National Climate Outlook Forum just about a day after, I think, the rainy season was declared this year. So you will have detailed presentation of the coming season that the climatologists will prepare, the National Climate Outlook Forum. And you could see that presentation again on our website, or the information with that presentation. Normally, systems east of 40 degrees west longitude, that is approximately halfway between the West African coast and the Eastern Caribbean, we should pick it up and report it in the 5-day outlook. And I have begun to go beyond the 5 days and extend to 7 days after the 5 days to try and pick up as much as possible development that is occurring within that extended period. Because if we do the 5 days, something might happen in 7 days and we would not pick it up. So we would be looking at all those extended outlooks, and we should pick it up. On reaching somewhere, I think the criteria or the operating procedure has changed a little bit. So forgive me if I don't get it exact in this presentation, because I had this presentation developed before understanding that. But on reaching somewhere near 40 degrees west, or maybe before, if the official state, or maybe before official statements are issued giving details of the possible threat to Trinidad and Tobago and the rest of the Eastern Caribbean, and the timing and spacing of the official statements will depend on the threat and the certainty and the time to impact and things like that. So sometimes you would see it every 12 hours, 24 hours. And sometimes we have it every 6 hours. I think for Beryl, we were going at 3 hours, so that would come into play as the threat increases. From 48 hours, we would issue watches or warnings according to the developing event, in conjunction with the common alerting protocol for the likely impact. So from 48 hours, we begin to issue and the watches and warnings for the potential tropical cyclone. A potential tropical cyclone can be announced 72 hours before to give us enough lead time in case this system does in fact turn into a tropical cyclone. But a watch is an announcement that lets one know that the weather system is likely to pose a possible threat to a specific area within 48 hours. And that is usually a watch. And a warning is the announcement which lets you know that the weather system or its associated conditions, which are important, pose a possible threat for a specific area within 36 hours or less. So in some areas of the world, you would see the sea conditions being posted as a threat that would occur in the times of a cyclone. So once there is possible associated conditions, you would have either storm watch or storm, a hurricane watch or warning occurring either within 48 hours for the watch or the warning within 36 hours. Tropical cyclone Beryl, I come to that. We would have seen how the watches and the warnings would have played out with Beryl, because it was very close to be seen there and it was strengthening. At one time it strengthened, I think, into category 5 for a short period, but it was given IO replacements and strengthening, and Tobago one time came under red level, common alerting protocol. Trinidad was under orange and things like that. But in this one, I'm using the Miami graphics, but it is similar to our official statement, which show a graphic like that. And we all work together in the world of meteorology in all regions. And you would have seen that Tobago would have been under hurricane warning. Tobago and just north of Tobago and the islands around St. Vincent, just to the west of Tobago, would have been on a hurricane warning. And Trinidad in blue was into a tropical storm warning. So we would have had all this other information taking place as far as the watches and warning, but also we would have it working in conjunction with the cap for the possible impacts, the red or yellow, as the case may be, for the possible impacts that might have occurred. So we have a kind of double tier system taking place there. It is a lot of work on the metro officers. I must pull a plug for my colleagues, because some people beat us badly when we don't get it exactly right. But yes, they have a job to do, especially with this fickle and changeable weather, what we call barotropic weather, which is very fickle and changeable in the tropics and the Caribbean. So we have a lot to do to get it right, and the people really are demanding that we get it right, so we try our best. So stay tuned for the meteorologist at PIACO. The National Hurricane Center is responsible for all the information you see in that depiction on your right-hand side. It is a regional specialized meteorological center for Region 4. and responsible for providing tropical cyclone watch warning recommendations to WMO Regional Association, which is Region 4, and the National Meteorological Service of Trinidad and Tobago is under Region 4. Trinidad and Tobago issue warnings for the islands and coastal waters of Trinidad and Tobago, the islands and coastal waters of Grenada and its dependencies. We are able to carry out its responsibility for warnings for these islands because of disruption caused by tropical cyclones. If we are unable because of disruptions caused by tropical cyclones, Barbados will take over. And if Barbados cannot take their responsibilities, Trinidad and Tobago will take over the responsibilities of Barbados. So we have serious responsibilities for our area, our coastal waters for both Trinidad and Tobago, Grenada and its dependencies. Now times and geopolitics has changed a little bit. So we are in a fluid motion, but yet we are usually very much in contact with Miami, and we have close collaboration and information exchange with Miami, the regional center. They will have the resources to send in hurricane hunters and things like that. And somebody asked about the numerical models. We all share information and technologies. So sometimes we do not need to really reinvent the wheel, but we work with what we have and what we can share with each other. We see the depiction there, and that is, I want to explain this cone that people tend to watch coming out of Miami, and what they call is the cone of uncertainty. And we notice the cone gets wider as it goes along. The orange color in that picture was the extent of the hurricane force winds. The orange circle just around Tobago there. And further out, we have tropical storm force winds. Now, this is what they call the cone of uncertainty. And it will give you an idea of how the hurricane or storm or cyclone will develop over time. Notice it gets wider. But this cone does not depict, per se, when the storm or the cyclone passes. It depicts and tries to predict when the center of the cyclone would most likely pass. I said the center of the cyclone. So as you watch that brown area, that orange brown area, you would see it is wider than the cone in that area, because it is only the cone of uncertainty is only speaking about the center, which means at certain times in the cone, according to where the cyclone center pass, you can still be affected by cyclonic activity outside, tropical cyclone activity outside of the cone. So if the center drops a little bit south of the center, Trinidad or the northeast of Trinidad may have had to come under hurricane warning. So I want to make that clear, so in the future when coming, you watch that cone of uncertainty. It is speaking only about the center of the cyclone. Okay, it gives good information, but just remember that. So what are the potential impacts to Trinidad and Tobago? Of course, various extents of flooding, street flooding, flash flooding. You have riverine flooding because of the cumulative effects, and riverine flooding could occur when the rainfall has stopped because we have the runoff still coming down from the higher areas of land. We have severe landslips or landslides, land erosion taking place. From tropical waves, the cyclones go right up. Even individual thunderstorms, we have strong winds. We have structure destruction. Just that the cyclones would have a more longer period of this wind occurring. Lightning discharges could cause potential for fires and the dangers of electrical shock. We have rough seas, destruction of seagoing crafts, swells, storm surge close enough. And we have, of course, God forbid, we could have loss. We have a lot of loss of property. We sometimes do have loss of lives in our region. And what to do in the case if we see? Well, take heed and prepare early, long before any weather event, even before at the beginning of the season. Know the area you live and the possible weather events could occur, such as if you're living on hillsides, know that there are possible landslips or landslides. You know that your area could flood at the drop of a bucket of water. No, you would have the experience to know how to operate with that. Stock up on non-perishable food items, lanterns, lighters, and water. Have your grab-and-go bags with medication, some cash, secure important documents in waterproof containers. Have a change of clothing, a blanket, medication. I think I mentioned medication for your grab-and-go bag in case you have to evacuate quickly. So the bare essentials, and prepare your property, get sandbags for potential flood areas, clean your gutters, canals, dispose of or secure loose items. Of course, secure your pets, please. Secure your pets. Know your neighborhood area for persons who might need help in cases of emergencies. Understand your area there may be aged people, there may be people who have lots of children and need help. So know that area in case of emergencies that you could tell the first responders where to go, how to go. They could pass what is a better route to pass with the heavy appliance if they need to. Know the DMU, the Disaster Management Unit phone numbers and where your shelters are. And also keep abreast of weather forecasts, reports, alerts or warning out of the Trinidad and Tobago Met Service and the ODPM Organization of the Disaster Preparedness and Management. From the NCOF, the National Climate Outlook Forum onwards, and other seasonal and daily forecasts. Sign up for the ODPM pans and the TTMS app. So go to your phone, sign up for the pans on ODPM, go to the App Store or the Play Store or the iPhone stores and see if you could download those apps so you could get the notifications as soon as possible. The pans have a different mechanism and a multi-pronged approach, so you could get in touch with signing up for the pans, PANS also. So you can do a lot of things before it happens. And my friend had asked a question. Good for her, she had secured a property. She didn't have to think the possibilities of this stuff, but it's something that you necessarily need to do, especially throughout the year, but especially in the coming of the season. Trinidad and Tobago Met Services and Products, we have a daily forecast. Somebody asked about that. We have 3-day forecast. We have 5-day outlook, and within that 5-day, there's some extension. At this time, we have tourism forecast out of Tobago, and give you, I think, it's about 3 days. We have agro-meteorological forecast. And the agro-meteorological forecast is not necessarily for agromet alone, but it tells you about the weather and the type of precipitation we might get in different parts of the country. So that is a good one for any and everybody to use. We have extended range forecasts. We have public warning systems like the CAP alerts. We have the El Nino Southern Oscillation Monitoring, El Nino La Nina Outlook. We have temperature and rainfall outlook. So somebody asks why we don't think about publishing these things. Yes, we do publish them, but there must be some pull from you on the part of, while we push a lot of it in different forums, different social media forums, there must be some pull on you to go and get. And in fact, I am advising all of you who are listening to me right now, get on to the www.metoffice.gov.tt site and just go through it. Get familiar with the site, all that it has to offer. So when time comes and you need a particular bit of information, without thinking like that with the snap of a finger, use your technology, get on and find the information that we have worked on to provide for you. Nobody should be without any extent of forecasting if they learn, go on the site and peruse it and learn how to operate the site, get familiar with the site. So we have a number of bits of information and products that you would be very helpful for you. You're on Facebook, you're on Instagram, you're on X. So I think we're on YouTube, you're on a lot of social media areas. Look out for us. I mean, we have all other peoples that are providing different types of weather reportings. And yes, I am not to say anything negative about the weather reporting, because what it does with efficient, effective, and true confirmed reporting, It does give people an alert and an idea is what is happening on the ground in case of a disaster. But it can become confusing at times. So I would advise the reporters and them if they could check in with the Met Office and find out what exactly is happening, or to share some information, and that we all could keep ourselves safe. And yes, you may like one social media product above another, but the official persons putting out net information is the Trinidad and Tobago Meteorological Service. And what we have is responsibility and accountability. We are accountable to the people of Trinidad and Tobago, and we are accountable to standards and world standards under the World Meteorological Organization. And our mandate is to give as best as possible the information to keep Trinidad and Tobago safe as possible, so people could prepare, all entities and stakeholders could prepare for any eventuality in the coming season and throughout the year. So I'll go on to the 2025 Atlantic hurricane season prediction. Robbie, you think I need to do any questions here, or go straight ahead?
Do some questions, a couple of questions there, and then we can continue. So we do have a couple that we can deal with quickly here. So, all right. So Donald asks, can a T-storm, I guess that means can a T-storm also be described as a microburst?
I think he's talking about a thunderstorm.
A thunderstorm, yeah.
Right. So the thunderstorm, I spoke about it earlier, the development and the destructive power and small time and area of a thunderstorm. We don't really call it storms or nothing. In fact, it's a small scale. Well, it might be big to you if it's falling over your head. But on the synoptic scale, on the larger scale, is a small scale storm that is actually happening. Within those thunderstorms, there are downdrafts. And sometimes with a sudden downdraft, sudden powerful downdraft is what they call a microburst. And yes, we have to be very careful with the microbursts, because I liken them, or I compare them with tornadoes to a certain extent. Also, they can pose severe hazards and threats to the operations within the landing and takeoff areas of the aerodrome. So yes, the thunderstorm, if the T-storm, it's a thunderstorm, would develop microbursts as the development takes place from time to time.
Okay, great. So another question, well, we have two persons asking, I guess, a similar question. So I'll just go through the two questions and a comment that the other person has made. So Rainman, that's an interesting pseudonym there. Rainman is asking, are we going to get an upgraded weather radar in the near future in Trinidad and Tobago, to replace the old one in Brasso Venado? So that's Rainman's question. Related, I guess, to that, Jamal asks, what are some technological systems being worked on or being put in place for tracking forecasts, example, live radar view? So that seems to be a related question to radar, but let me just get to comments. Well, Jamal also made some comments about, I guess they're sort of technology-related comments about Grafana, LoRa, and GPUs. All right. Okay, so let's deal with the radar question. Let me just repeat it. Are we going to get an upgraded weather radar in the near future in Trinidad to replace the old one in Brasso Venado? And what are some technological systems being worked on or being put in place for tracking forecasts, that is live radar view?
Okay, I didn't intend to speak about the radar this evening, also more on the meteorology. Of course, I said it the last time that I'm not prepared to speak on it much, but everybody knows we have been having some problems, technical problems with the radar. It is an old radar, and sometimes radars and technologies become outdated, and we have been having some problems with it. It has been working off and on sometimes. I have been using it within recent times. As far as that question goes as to when things might occur, there's a lot of administration and problems as far as funding and technologies that is out of my purview that I do not always understand. So I can speak a lot about meteorology, which I understand somewhat, but I don't want to venture on this forum um, any information that as to when and how the radar will be fixed. But what we do, we work with what we have, and we have been working sometimes, a lot of times without the radar, but we have been producing as much as possible. We would realize that within the last couple of years or last few years, that if we take a comparison for any time before that, 10, 15, 20 years ago to now, if you look at a line drawn as far as the developments in the Trinidad and Tobago Met Service, you would see a steep improvement in a general sense in the products we produce, and especially in forums like these and social media forums. So there is development in some areas. There's extensive development in some areas and progress. And then in this one area, we are having a little bit of problems. So yes, if you look at the overall view of the Trinidad and Tobago Met Service, we have made extensive development over the years. We have been able to push a lot of new products and develop some older ones. And yes, we are producing for the nation, but I cannot give you any in-depth or satisfactory information as to how the fixing of the radar or the procuring of a new one would take place within the near future. Maybe you can write to the Met Service and an email and ask the question, and those in the higher ups, maybe they may have an answer for you in some better form that I have done.
Okay, fair enough, Gary. Thanks so much for that. So, folks, we have a couple more slides to go. We have the Atlantic hurricane season predictions, the 2025 season that starts tomorrow. I know a lot of people are interested in this. And we also have climate change and global warming. So we have, because we do this for you, we are taking the questions, and therefore we're running a little bit longer than we may have otherwise. But again, the question's excellent. So we can still probably take a couple more questions towards the end, and that number to send either an SMS text or a WhatsApp message will be 1-868-74-REACT. That is, works out to 747-3228. 747-3228. Again, the area code 1-868. I know we have been getting a couple of questions from up the Caribbean as well, and we welcome all who have joined us and spending the evening with us this evening. All right, so let's continue with the rest of the presentations. Gary, over to you.
All right, thank you, Rob. So we look at the Atlantic hurricane season prediction. These predictions were done by the climatologists at the NCOF, and you could go on the website and find them, all the different types of predictions. You could research it, and these are the names that they have put forward for the hurricanes this year. You could also get that on any platform, on any website. Search the sites, and you could get this, because I've done that. So for AccuWeather, which some of the tool uses AccuWeather and Colorado State University, and of course we use the National Hurricane Center. So looking at AccuWeather, AccuWeather gives a range, and the 30-year mean is 14 named storms and 7 hurricanes. 3 of them go on to be major hurricanes, and they talk about impacts for US. But their forecast is between 13 to 18 storms and 7 to 10 hurricanes, and 3 to 5 major hurricanes for the Atlantic Basin. For Colorado State University, the average, of course, is 14.4 storms, 7.2 hurricanes, and 3.2 major hurricanes. They did an arithmetical average. So this year they are forecasting 17 named storms, 9 going on to hurricanes, and 4 major hurricanes. So they are predicting an above normal season. So the one we look at is the NOAA 2025 Atlantic hurricane season. NOAA is also predicting a 60% chance for above normal and a 30% for near normal, so 90% for near normal to above normal, most of it being looking to be above normal hurricane season. They are looking at the number of named storms to be, of course, the average is 14, 7, and 3 for named storms, hurricanes, and major hurricanes. And we are looking, Noah would give you a range, so we are looking at 13 to 9 named storms, 6 to 10 hurricanes, and 3 to 5 major hurricanes. Of course, we know that Noah is looking with the highest probability for above normal season. And the season is expected to be above normal due to a couple of factors coming together, which includes the El Nino Southern Oscillation, neutral conditions, the warmer than average ocean temperatures. And there's a forecast for weak wind shear. I explained the wind shear earlier on, and high activity over Africa, which is the starting point, as I could explain the starting point for the tropical waves. And all of these elements come together to provide a higher probability for the development of cyclonic activity. With the Trinidad and Tobago, we do a forecast for our area of interest. And because, again, of the El Nino Southern Oscillation conditions of neutral conditions, the neutral condition exists for central and eastern tropical Pacific Ocean, where the El Nino normally resides. The sea surface temperatures in our area of interest, including that portion of the North Atlantic warm pool, east and southeast of Trinidad. And this Atlantic meridional mode, which is the sea surface temperature gradient between the North and South Atlantic Oceans and the tropical Atlantic Ocean. All of these come together to inform the analysis of what the climatology would have done. The sea surface temperatures, while they may be cooler than last year was very, very warm, but they are still warmer than normal this year. So while the prediction is for an above normal season, they did not go as high in their predictions as far as the amounts of development for this year occurring as with respect to last year or in relation to last year. So yes, about normal temperatures, but not as warm as last year. So we are looking at, again, likely number of storms in our 2025 forecast. Incidentally, in that area of interest, once again, the average for storms is 4, and 1 likely to go into hurricane. So our forecast is 1 to 5 likely named number of storms. Most likely number is 3, and hurricanes between 0 and 2, and the most likely number is 1. So therefore, our predictions are looking at a mostly normal of 43% for normal development within our area of interest, and above normal 38%. So mostly normal, tended to above normal at times for our area of interest, as far as the development numbers are concerned. But it takes, as we like to say, it takes only one. So let us be prepared, like my good friend who already prepares the roof, let us all be prepared, because whether we say above normal and the numbers or below normal, it takes only one strong storm to any one of our islands of the Caribbean and Trinidad and Tobago to set us back some years. So let us all be prepared. This is the entire wet season outlook. I'll just give a brief on it. But we're looking for near normal rainfall, most likely for the entire wet season. And near normal usually means between 75% and 125% of the long-term average, which is expected for the particular month and collectively for this season. So if a month we get anywhere between 75 to 125%, we will call it normal. Or if we get above 125, it will be above normal. And if we get below 75, it will be below normal. So we're looking at that range of normalcy, so to speak, for the wet season coming up. And the potential for accumulated rainfall. I won't go through all the detailed figures, but we see the highest accumulations is in that eastern and northeastern area of Trinidad, and in the western peninsula area, we're looking at lower than normal, where the central areas fall somewhere between between there. But the thing to note is that the higher ice accumulation is in those areas, in the eastern and northeastern areas of Trinidad. And some of the higher potential is on the central coast, windward coast of Tobago. Not as high as Trinidad, but still within the greens as far as accumulations are concerned. So we like to go to climate change and global warming, and maybe we'll take questions after, so that when we get through the climate change and global warming, I don't think it's a long session, a long area, but climate change and global warming. Climate change, we often mix up the difference between climate change and global warming, but they are not the same, but in our time, they represent nearly the same. Climate change, observe the Earth climate, observe changes observed in the Earth climate since the mid-20th century have been driven mainly by human activities and basically by fossil fuel burning and increasing the greenhouse gases in the atmosphere, and therefore raising the average Earth's surface atmospheric temperature at an alarming rate. And this causes changes in the climate. Now, global warming is the increase in the temperature, resulting in effects causing changes in the average weather patterns, which we refer to as climate change. So the climate could be changing for different reasons. If we were in another time, some thousands of years ago, we could have had global cooling and the climate would have been changing then. So because in this time our climate is changing because of the warming of the globe, we kind of use the terms interchangeably, global warming and climate change, but the climate is changing because of the global warming. So human activities are the main. We have increased, our industrialization has increased, so the level of greenhouse gases in the atmosphere have increased. Some of the main greenhouse gases are methane, carbon dioxide, and even carbon dioxide and methane. Methane causes over 100%, 50% of, and carbon dioxide over 50%, and it continues to increase. And the climate cycle, the carbon cycle takes thousands of years. So even if we stop right now, we could see take a long time before the you could see results taking place. So we need to put things in place from now to at least slow down the climate change and the effects. And some of the expected weather consequences of climate change, we could see a rise in sea temperature, which we are seeing, increase in hot spells and heat waves, which we are likely to have, and we have seen some over Trinidad and Tobago and some of the Caribbean over the last couple of years. So we could see an increase in those things happening, and those could be devastating for pets, the elderly, and the very young. We have increasing ice melt and therefore reduction in the areas that we have ice or semi-permanent ice on the globe. We have droughts in areas where it might not have been normal to have droughts. We have intensity or an increase in the intensity of a number of tropical cyclones. We have extreme flash flooding events, increase in riverine flooding, intense precipitation events, and change in precipitation patterns, which makes it difficult to predict for the meteorologist. And especially now that we have neutral conditions with the climate change, it gives a kind of increase in difficulty for prediction. The rise in sea levels would result in saltwater intrusion into freshwater areas and courses, and coastal and low-lying reclamation by the sea. And we also have what we know as coral bleaching and loss of coral reefs. There are some consequences also for the socio-economic and environmental effects. We have economic stress. Some people could lose their livelihood by this reclamation of the beach. We have potable water insecurity, I should say, that we may not have as much drinking water, enough water for drinking purposes. We have changes in biodiversity, which because of the warming invasive species the spread of vector-borne diseases because these species might be able to survive in areas which they were not previously able to. The loss of human habitat spaces, change in settlement areas, the type and sizes, and where we put the settlement areas. Degradation of ecosystem, both on land and sea, and likely to decrease the ability to provide food production from the sea, local manufacturing inputs, and tourism inputs, etc. I just want to take a time to see these pictures. The Uriah Butler Highway on the 20th of October 2018, that great flood. These are some pictures that shows a possibility, while this may have happened because of certain types of cell and certain things coming together, including the ITCZ, and we had that flooding. This is the type of flooding, and more than that, we could expect in the times of climate change, even worse than that. We have that same flooding for St. Helena. I'm just showing the pictures to show the possibility of the types of flooding, which we have already been subjected to. In Kelly Village, you see the height of the water there. And the person took their pirogue and went out to try and save some people. So we have to help each other with whatever resources we have. And so be prepared to help sometimes. We also have this picture, takes a picture. We could recognize the area or the sheltered areas of Trinidad, and rough seas conditions could occur. And imagine if there were boats or anything in the area there, they could be destroyed because of the rough sea conditions. So these are the type of things we could possibly understand with climate change. I always use this example, a gentleman by the name of Abdul. I took this some years ago, a couple of years ago, from Facebook. And I thought what he was saying, if he was saying is true, that I could use it. So I give him the credit, Abdul, that the effects, and he said the effects of coastal erosion in Icacos, Trinidad. And he took two images, two he said 2 years apart. One was in 2020, and the other was in 2023. And he showed us those two pictures of what happened. And the picture from September 2020 showed a certain integrity with the coastline, and notice the red door in the center of the picture there, the building with the red door. But when you look at the second picture 3 years later, the building with the red door was a good few feet. I don't want to estimate, but about 50 yards, I don't know, from the sea. But on the second picture 3 years later, the big sun was already up on top of that building. So these are the kind of things that you could look forward to. And I'm just citing Mr. Abdul. I'm using the pictures to show what is possible in the time of global warming or climate change to happen as far as the sea beachfront are concerned with reclamation of the land. So I like to quote important people in our time. So if we are to weather these storms, we must be united in our effort. There's no doubt about it. People from all walks of life, professional scientists, everybody must have to come together. We saw the picture with the guy who usually carry people on tours in the Caroni Bird Sanctuary, using his pirogue to go and help people out of the flooding situation. So if we are to help each other, or if we are to be effective in weathering the storm, we must help each other and come together and united, not just professionals, not just scientists, but everyone from the ground up must from now come. Because they were saying we all live downstream. You throw your garbage in the canal, it will go downstream and flood somebody else, and somebody upstream would flood you. So I put in Robert Nesta Marley, who we in my time know as Bob Marley. He says when the rain falls, it don't fall on one man house. So we must remember that. And also in the same unity, I would be remiss of me not to quote Dr. Leroy Sylvester Callis, which we knew as Black Stalin. And he said, so we must push one common intention for a better life in the region, for we women and we children. And that must be the ambition of the Caribbean man. That was taken from the song, The Caribbean Man. And it pushes the theme and the sense of all of us. It becomes necessary for us to work together in order to weather the storms of these weather effects and the possible changes in the climate. So, ladies and gentlemen, it has been a long presentation, and I've tried my best to give as much as possible. I was not able to give everything, Robbie, but I can still put you in a position that you could go on and find out more in the coming days. Of course, look to the Trinidad and Tobago Met Service website. Don't always look for us to push things for you, but go to the website, be familiar with it, and try to pull as much as possible. It is imperative, it is important that we do our work and you do your work, and we work together for a better region for women and the children. Thank you, and we could take some questions now.
Excellent indeed, there, Gary. So I don't know if you want to unshare your slides now so that everyone who may have joined after could see what you look like. I guess everyone should know what you look like already. All right, so excellent, and I love the slide just before the last there. Well said indeed, well received, and based on the feedback that we're seeing on the social media platforms as well, the participants, the attendees really appreciate your exposition. So I think we have two more questions that I think we have not addressed. So let's just get to them quickly. I know we are often on in time, but again, we do this for the participants. So once there's interest in questions, we will do our best. So just quickly, Anton asks, why is there rain after a yellow alert is canceled and turned to green level?
You know, that's a very interesting question. And I'm glad he asked it because I forgot to mention it. And it is an important question, so I want everybody to understand what I'm saying to you this evening. And you can teach others and spread it. Anton is the person, Robbie? Anton?
Yes, Anton.
Anton, yeah, what happened? The yellow level, the CAP, Common Alerting Protocol, is for the effects of the weather system. It's for the possible impacts of the weather system. And we are in the rainy season, and rain will fall, and we would not have cap rain. So sometimes when we have the rain starting to fall, and the cap doesn't come into play until a certain time, because we think in our estimation and understanding of the weather that the severe impacts that warrants a yellow level or whatever level color cap would not come into play until a certain time. And then we would seize the cap and go into green level. Incidentally, green is only used for the cessation of a cap. So we will go into the cessation of the cap because we believe at that time there is no longer a threat of the impacts of the weather system or the potential threat of the weather system. It does not say that rain will stop falling, but it says that the threat has been reduced to such an extent that it no longer warrants a cap. So you would most likely, because the weather doesn't have a serious breaks. Sometimes it takes a time before it tones down and settles, before the sun comes out, if the sun have to come out. But so we would stop the cap to get everybody back to normal, because we don't want people to be under the stress of this cap all the time. So when we feel the impacts of the weather has lessened and not likely to continue to increase on a downward trend, then we could stop the cap, and of course rain could continue falling because this is not as threatening or as impactful as the time of the cap.
Okay, excellent indeed. And I think that's a question I've heard people ask on social media. Sometimes when it goes green and like 2 minutes later, someone says, well, we're now on green level and look at rain, right? So very good question,
Yeah.
Anton, and excellent response there.
A hard, short, sharp shower. Not moderate, but a heavy, short, sharp shower. When the cap is, may just start to fall over your house or your village. But for Trinidad and Tobago, the extent of the weather has reduced. And you would say, but they just stop the cap and the rain now start to fall hard. You could get street or flash flooding. Not flash flooding, but you could get some street flooding and puddling after the cap has been gone. It just means the extent of the threat has reduced, and it no longer puts it into the yellow level of the cap.
Excellent indeed. All right. So we'll do one more question that we have queued up here. And Shivi asks, how is a tropical wave identified so that they mark it with the slanted line. So I guess that's on the charts. How is a tropical wave identified so that they mark it with the slanted line?
Okay, I explained the tropical wave, how it starts, how it comes about in the form, shape of a wave. On the peak of that wave, where the sense of turning remains one way because it is a trough. So we have a sense of counterclockwise turning in the wind. It goes generally from southeast to east to northeast. At that point, there's a line mark in the center of that curve, which we call the axis. The axis is not a tropical wave. That I had explained. The tropical wave is a synoptic feature. It is hundreds of miles wide. And what the line most people look at is the axis. I always take time in my products to say that it is the axis. It is not the entire tropical wave. So we look at the center and a notional center. If you were to draw that line from the peak of the wave to the idea of where a center would be if you had continued the circulation right around the drawing. We take that line from that notional center to the peak, and that is where the axis occurs. And before the axis, we would usually have some divergence, and after the axis, we would have most of the time convergence. So you would see that line, some cloud development upon the axis, and then after the axis, you have some trailing convergence. And also it could modulate the ITCZ and continue the weather after. But that line is not the entire tropical wave, it's just the axis. And it is put there just in the notional center of the arc. Like if you draw that line from where a center would be, if you continue the arc in a circle, to draw that line from the center to the peak of the arc, that is where the axis is. I hope that answered the question.
I'm sure it does.
And then and also we could also look at the cloud signature, because people looking at the satellite picture when you see the cloud signature, but they not see the wind. So the cloud signature could develop anywhere along the arc of the tropical wave. That is the wind we're looking at, the change in wind direction that we're looking at, the convergence in between wind and divergence that we're looking at to see where the tropical wave is.
Excellent indeed, Gary. So I think that's about what we will take. I know we are a little bit on overtime. We had tried to go for 2 hours, but I see we ended up at about 2.5. Not too bad in the sense that we are addressing questions and concerns and comments. I mean, we had quite a few comments on social media as well, YouTube, via WhatsApp. Love the running commentary and the interests. So I think it's time to bring things to a close there, Gary. Very well received, I will say, based on the comments that we are seeing on social media. So this has certainly been an engaging and interesting presentation on the topic of weather systems and their impacts on Trinidad and Tobago. In bringing this evening's event to a close, we would like to thank the ODPM and TEMA for conceptualizing the NDPPM and putting the overall program together. Special thanks to the CEO of the ODPM, Major General Retired Rodney Smart, and Operations Manager Dennis Marcel. Lieutenant Commander Kirk Jean-Baptiste and other ODPM staff, and the Director of TEMA, Alan Stewart, and support staff for their kind assistance and encouragement. A hearty thanks to the Trinidad and Tobago Meteorological Service, TTMS, Mrs. Arlene Aaron Morrison, Acting Director, Mrs. Camille Hall Graham, Communications Officer, and Ms. Tennille Skeet for the collaboration. And most importantly, the presenter for this evening, a legend in his own right, Mr. Gary Benjamin, Senior Meteorologist, without whom today's event would not have been possible. Before the other closing remarks there, Gary, did you have anything else that you wanted to say before I wrap up my final comments?
Yes, well, I just want to say I appreciate the interest in the weather patterns, of course, is necessary. I appreciate you, Robbie, because without you, I would not have been on this panel. I appreciate your recognition of my expertise in certain areas. And this is why you spoke to me about this some years ago. I jumped at the opportunity because that is my life. That is my spirit to teach people things. And I just want to say that when we have these type of forums, I hope it's not just a talk shop. I hope people go over, look at the recordings again if you missed something, and please try to develop what's the word I would use, a culture of checking the weather and the weather patterns in your life. It is very important to you. Develop the culture. When you jump on your social media to go and look at other platforms, spend 10 times, say your prayers, spend 10 minutes, or how much time is saying your prayers, and then spend 5 minutes looking at the weather. It is important enough, and then go about your life and keep checking on the weather programs. And thank you again for everybody out there. I'm not seeing the comments, but for whatever kind of comments you have, even if it's negative comments, I would like to see them to see how I myself can improve, because when I do these things, it's a learning session. You may think I know, I certainly do not know everything, but it's a learning session for me and for all who are involved in these type of forums. So once again, thank you. Have a pleasant evening, and I hope a safe season, and take care.
Well said indeed, Gary. And of course, you have also been on a previous in 2023, where we had that collaboration with Eric Mackey, Colin Hussain, Mr. Weatherman, Brian Shields, and yourself. So it's great to have you as an exclusive for us to get all of this knowledge and information. Indeed, I know you would have done an outpouring, a dump of a lot of information in a short time. So it'll be great to have you back. I'm sure there are more questions that we can answer as well. So just to wrap up my closing comments, so certainly thanks to all attendees who were part of the live audience and those who fielded questions, comments, for spending the evening with us as we do this for you. The recording should be available via the same link for looking over any aspect for persons who may not have been able to attend the live stream. I'll tell you, I for one, will need to look it over as well. There's a lot of information, new information in there, and having to conduct this webinar, I would not have been able to pay pristine attention to everything that Gary said. So I for one will be looking it over. This is a lot of textbook stuff as well, very practical application. And certainly a special thanks to our streaming provider, Heartlight TV, its CEO, Charmin Williams, Technical Director, Bert Williams, and staff for making available the required technologies and facilities, enabling us to host today's virtual panel discussion. Thanks to the Chairman and Board of Directors of REACT International, the presidents and teams of the REACT Trinidad and Tobago Council, REACT members and their families, fellow communicators, colleagues in the amateur radio fraternity, the Zello communications partners, and CB radio operators for their support and various contributions towards making this event possible. Look out for other sessions in the future. To get in touch with REACT, please call, text, or WhatsApp 1-868-74-REACT, the same number that we have been giving all evening, or email us at info@ttreact.com. Check us out on our social media platforms and consider interacting with us via the public Zello channel, REACT members. Persons interested in becoming a licensed amateur radio operator, we have free online training or prep courses for the American exams, which can also be used to obtain a Trinidad and Tobago ham license. Again, contact us, same number, 74-REACT via WhatsApp. That's the best way. So thank you. Wishing that everyone, each and everyone and their families continue to be safe. Do have a good night.